Dielectric elastomers, shape memory alloys, and piezo ceramics are smart materials. These three intelligent materials react independently to the changing environment. They change their form on encountering different external stimuli. There's something magical about this effect and provides us with a new perspective on materials and how to think and to utilize them. Dielectric elastomers are mutable plastic materials. Dielectric means non-conductive. Elastomers are plastic materials that have a solid form but are able to bend and stretch. In order to turn dielectric elastomers into smart materials, flexible electrodes are coated onto the top and bottom sides of very thin elastomer films. If you then integrate these sandwich materials into an electric circuit and apply voltage, the oppositely charged electrodes will attract one another. The elastomer film will get bigger and thinner. This causes the electric energy to be turned into mechanical energy. And the remarkable thing is, it's a reversible process. DEs can, depending on application, be rolled or stacked. They adapt perfectly for specific demands. This type of smart material has a lot of properties that makes it attractive to engineers and designers. It is lightweight and reacts extremely quickly and with high precision. It is also highly stretchable and therefore extremely suitable for flexible structures. In addition, dielectric elastomers can generate small amounts of electric energy. Science is currently working on optimizing the material composition of dielectric elastomers in order to reduce necessary voltages. Thermal-shaped memory alloys are metals with a capacity for remembering. Thermal means that the shape memory effect is triggered by heat. This specific alloy determines how the metal behaves at different temperatures. SMAs are intelligent materials because they are programmable to take on any desirable form and will always remember it. They return to their original form as soon as they've achieved the specified temperature. To recreate this effect, the alloy will have to be deformed again. This is mostly done with a counterweight. There are several ways to generate the heat energy necessary for this. Either you use ambient heat, such as sun rays, or if the effect needs to be triggered precisely, the necessary warmth will be generated through an electric current. SMAs can be as thin as a piece of hair or as thick as a spring or even a plate. This smart material moves fluidly and slowly. It is lightweight but able to generate a lot of strength. It also doesn't rust and it is biocompatible. It's a good choice for integrating into other materials and flexible structures. It also has the distinctiveness to be extremely bendable under specific conditions and able to return to its original form on its own after being deformed. Piezo ceramics are multifunctional ceramic materials. They belong to the group of technical ceramics and consist of a complex chemical composition of materials. The term piezo derives from ancient Greek and means push. It describes the resulting electrical energy if a solid object is deformed. If you apply electrodes to a piezo ceramic and connect it to an electrical source, the ceramic will compress or stretch, depending on its polarity. This effect can also be reversed. If the piezo ceramic is deformed through pressure, electric charges will be generated inside the component. These small amounts of electric energy can be removed from the component and used. If an alternating voltage is applied, the ceramic will shake so quickly that the vibrations can be perceived as sound. Depending on how they're used, piezo ceramics can be large and stiff or small and to a certain extent even flexible. They can be available anywhere between thin films up to solid objects, which allows for lots of creative leeway. The piezo ceramics deformations are tiny and can't be seen with the naked eye. The resulting forces, however, are comparably large. Piezo ceramics react lightning fast and are extremely precise. They are robust, durable, and inexpensive compared to other standard components. The potentials for technology, design, architecture, the arts, and many other fields of everyday life are far from being exhausted. Here, research and design are just getting started.